What's going on YouTube? Bringing you another video right now. This one is on similar right triangles and geometric mean. So we are putting the pieces together on how to use geometric mean in word problems. You see what I did there? Puzzle pieces? Yeah. Alright, so for this video, the learning target is to, again, prove theorems about triangles. Now, the success criteria is telling you a little bit more of what that actually means. For me, in this one, it means that you'll be successful when you can use geometric mean in word problems. Okay, so we are now on page 3, specifically number 5. So in this one it says Corey is visiting the Jefferson Memorial with his family. He wants to estimate the height of the statue of Thomas Jefferson. Corey stands so that his line of vision to the top and the base of the statue form a right angle as shown in the diagram. About how tall is the statue? Now I know that the picture is kind of hard to see, so I actually redrew it down here. When you're looking at it, it's a lot like the problems that we did in the video before. In that video, we were taking the geometric mean of these right triangles, so we would break it up into 3 different triangles. So you would have this medium-sized one, and then you would have the small one, and then the full thing. So this is going to be just like that. Now, one thing you noticed, where they gave us the values, that's not actually on any of these triangles. So I have to make sure that it is on there. Now if you notice with these dotted lines, it actually makes it so it forms a rectangle. So in a rectangle, the widths are the same value and the lengths are going to be the same value. So this 5 foot 8 inches is also on this side. And then the 8 foot 8 inches would be right here as well. So now we are going to use these to figure out the height. Now one thing that I'm going to do is, it's in feet and inches. I'm going to try to make it all into one. So to make inches into feet, there's 12 inches in a foot. So what I'm going to do first is do 8 divided by 12. That will get me 0.6 repeating. So I'm going to go ahead and round it to 0.67. So instead of 5 foot 8 inches, I'm going to have 5.67, because when you take 8 inches out of 12, you get 67%. So that's 67% of a full foot. So that's what I'm going to be using instead of the inches in the rest of these. So first thing now is to redraw the different triangles. So I'm going to have my small one, my medium-sized one, and the full-length one. So now I want to put the values that I know in there. So with the small one, the longer leg is 8 foot 8 inches. So that side would be 8.67. The shorter leg would be 5 foot 8 inches. So, or 5.67 with what we found earlier. So those are the two values that we know right now. Now, I don't know what the length of this side is in the medium one, the long leg. And I need that to find the full length. So this is what I am trying to solve for at the moment. So on this side, I would have my x. And then the short length here, the smaller leg, would be the 8 foot 8 inches, was 8.67. So now, and then when you look at the full thing, I don't have a full length value for any of the sides in the full triangle, so I'm leaving that like it is. So the ones I'm going to be using is the small and the medium-sized triangle. So now I'm going to set it up with which ones go with which. So the short leg, 5.67, goes with this short leg here, 8.67. So what I would have is 5.67 over 8.67. Now I'm going to look at the other leg. So since I started with the 5.67 on this one, I'll start on this triangle again. So 8.67 goes with x, because I don't know what that length is. Now that I have done this, I want to do my cross multiplication. And 5.67 times x is just 5.67x. And then 8.67 times 8.67 is 75.1689. I want to get x by itself, so what I'm going to do now is divide each side by 5.67. This is so the 5.67 on this side gets canceled out. And what I get is x equals 13.2573. Now, I'm just going to go ahead and round this to 2 decimal places. So I'm looking at this number here. Well, there's a 7 on the right of it. So since that's bigger than 5, I'm going to round up. So I'm going to have 13.26. So the value for x is 13.26. Now, if I want to find the full height of the statue, I would need to go from the base and whatever x is. So I'm going to combine those numbers and add them together. So that means I'm going to do 13.26, because that's what our x equaled, plus 5.67, because that's the height of the base of the statue, which was given to us earlier. Now I'm going to add them together and get 18.93 feet. So our answer is that it's 18.93 feet. Okay, so now we're on the same page, page 3, looking at number 6. Now, part A says, given the picture below, explain why the triangle ACD is similar to triangle CBD. So just in case you didn't remember, that symbol means that they are similar. So in this picture, I have the big triangle has a 90-degree angle, the small one has a 90-degree angle, and in case you didn't know, if this side's 90, this side is also 90 because it forms a straight line. So every single triangle has a 90-degree angle, and they also they share different angles. So because they have at least 2 angles that are congruent with each other, that means that they are similar because of the AA postulate. So for part A, it's because of that AA postulate that we know that they are similar. So part B now says, now prove the length of the altitude of the hypotenuse of a right triangle is the geometric mean of the lengths of the 2 segments of the hypotenuse. So first thing, the way we're going to prove it is we're going to draw our 3 different triangles like we've been doing with the problems from before and the ones that we did from the last video. So we're going to have our small triangle, our medium-sized triangle, and our large triangle. So for the small one, E is the shortest leg, so I'm going to put that right here because of the way I redrew it. Because remember, I had to rotate it to make it look like the way I drew it. And then B was the hypotenuse for it. So, sorry that skips a little bit. There's a little bit of a technical issue, and I am not a tech guru. But what you just saw was I did the small triangle, and I labeled where they were. For the medium triangle, I got F because it was the longer leg, so I put that there. And then A was the hypotenuse, so that's always across the 90-degree angle. And then for the big triangle, A is the longer leg, so I put it there. B is the shorter leg, so I put it there. And C was the hypotenuse, so that would be the full length. So that's where I got all of these. Now, they want me to look at the altitudes and make it so that they go with the hypotenuses. So if you don't remember what an altitude will start at a vertex and form a 90-degree angle. So all these sides that start at a vertex and go down and make the 90-degree angle are actually altitudes. So E right here is an altitude, F right here is an altitude, A and B here are also altitudes. So first one I'm going to do is I'm going to try to do the small one here, and I'm going to combine that with the one here. So I'm going to combine the small triangle with the large one. So E is the short leg, so I'm going to combine that with B. So E over B equals, and then we have the hypotenuse just like they were asking for. So B would go with C. So now you would do your cross multiplication. So E times C is EC, and that equals B squared. So if I did this portion here, E, multiplied it with the full length C, that would be the same thing as whatever number I would get if I did B times B, because that's what B squared means. All right, so the other one that I want to look at is now I'm going to combine this one here with the large one. So the medium, because it has this altitude F, and I want to combine it with the large triangle that has a variable for each side. So for this one, F is the long leg, and that goes with A on the large triangle, so F over A equals A, the hypotenuse, which goes with C. So now I do my cross multiplication. So A times A is A squared, and F times C is FC. So if I multiplied F times the full length here, C, that would be the same number as if I did A times A. So if I did A squared. So because of what I'm seeing here, what this actually lets me know is if I did A squared plus B squared, it would actually equal the full length of my hypotenuse. And this is actually a formula that we're going to start using very soon, and this is called Pythagorean theorem. And we will use this formula a lot in our right triangles unit. Thank you so much for watching. This is the end of this video, and make sure that you do exit ticket number 2 so that you can prove mastery of what we just went over. But again, thank you. Make sure to like, subscribe, ring that bell, all that jazz.